Arthur. And essentially what that means is that I work with our customers, specifically the data science teams, to help them strategize on how to monitor their models for things like performance, explainability, and what we're going to talk about today, which is fairness. I tried to put together some of what I thought might be the most relevant pieces of information for anyone that's starting or continuing to think about how to create ML systems which are more fair. But I imagine you all understand your use cases far better than me, and probably have a lot to bring to the table. So I would appreciate if you speak up with comments or questions in the chat, because I think that as you probably know, this is a kind of a conversation which is just going to continue to evolve as the technology develops. But I thought a good place to start would actually be with these recent prominent examples of models which have been deemed biased or unfair. So that is, like AI sending the wrong people to jail, healthcare algorithms being biased, computer vision systems being, showing racist results, Amazon's recruitment algorithm being biased against women, and the list goes on. This is just, what I've pulled recently. And I put these headlines up here, not to shame, the companies that are involved here, but really to point out how pervasive this problem is, right? Machine learning has use cases spanning the criminal justice system, transportation, hiring, and these are some of the most technologically advanced companies in the world, and we're still having this problem with models which are biased or unfair, right? So this is a problem that I think we all need to address, and I imagine many of the people on the call today have models which are directly impacting people's lives, right? So I think we all kind of have or should have a sense of responsibility about these algorithms which have direct impacts on people's lives. And if that's not enough motivation for you, I mean, you could also consider, the reputational risk involved, right? If you have an algorithm that has been deemed, biased or unfair towards a particular population of people, right? And this is something that regulators are recognizing as well. So, New York City, for example, just put forth this hiring law that requires a bias audit be conducted on any automated employment decision tool, right? And this is just the start, right? I mean, New York City put forth this thing, but I imagine California is going to follow soon after, and then basically all other states are going to follow. And then at the federal level, Congress has introduced this bill, the Algorithmic Accountability Act of 2022, which requires companies to conduct these impact assessments for bias. And they're a little more general here, right? So notice that they're using the term like, any automated decision system that makes critical decisions. So this is going to go well beyond hiring. And, this has just been introduced, but, I imagine in the near future, these bills are going to have a lot more teeth. And so I think that whether you're not intrinsically motivated or motivated by the fear of reputation, a brand risk, I think that legality is pretty soon going to be, forcing us to be thinking about how our models might be biased or unfair. So I think it would be worth taking a moment to think about what are potential sources of bias, right? And so I've pulled this figure from a recent paper, which I really enjoyed, that kind of outlines the kind of machine learning, maybe life cycle, I would say, that starts at, the data generation and ends with actually deploying a model into the world. And I'm not going to go over every little detail here, but, highlighted in red are all of these, potential opportunities for bias to seep into our models, right? And kind of at a high level, you all probably understand that machine learning models are trained by providing a model with a very large number of examples, right? And traditionally those examples are decisions that were made by humans, right? And so, as you all are probably aware, humans are subject to their own biases, right? So if we are training our models on decisions that were traditionally made by humans, then we were probably just propagating the biases that have existed historically, right? And so that's what's referred to as historical bias, kind of early in this pipeline. And then there's also things like, representation bias, which is, how did we decide, what types of individuals or what types of decisions were included in, say, for example, our training data set, right? Or measurement bias, like what actual, features or metrics are we actually measuring and providing to those models, right? And that's kind of a lot of what's going on the data generation side. And then, later on in that pipeline, when you're deciding and training, deciding on your model architecture and training that model, bias can seep in based on how you're optimizing that model, or what types of groups of individuals you're including in your, say, training data set, for example. And then, of course, when you're deploying that model out into the world, that's another opportunity for bias to seep in. Like, what circumstances are you allowing this automated decision-making system to make decisions that are affecting your business, or your stakeholders, or your customers? And so, let's say we have an understanding of potential sources of bias, right, that can seep in at all these different points in our pipeline. I would say that, like, after dealing with customers, the most common response I get when talking about fairness or bias is that this approach, which we sometimes call fairness through unawareness, right? And the idea here is that, let's say you have a model that is predicting, an outcome for a group of people. Now, a common misconception is that, like, oh, if I just don't include information about an individual's race, then, I've avoided the problem altogether. Like, my model doesn't know what the race of an individual is, so it can't be racist, right? And hopefully you all have a sense that of where I'm going with this, and that is essentially that this does not work, right? There are tons of proxies for all of these, sensitive attributes, like, race or sex, for example, that would be a pretty clear, or pretty close to, clear indication of what the race of an individual is. So take, for example, zip code, right? You can imagine that, knowing information like the zip code of an individual, and even, combined with, say, their last name, would give you a pretty good sense of what the race of the individual is. And this is, if you think about it, this is what machine learning systems are designed to do, right? They're designed to generalize or make predictions about whatever, based on a limited amount of data they get. So if you have data on the purchase history of an individual, or a zip code, or whatever, it seems like it's pretty possible for machine learning systems to make that educated guess on what the race of an individual is, right? And so this approach really just does not work. And this is not going to be a good enough excuse for regulators or journalists that are looking into your models to see if they are biased, right? Just by not including this information, it's not enough to prevent bias and unfairness from kind of seeping into your models. And so what, now one of the best practice approaches that people are kind of coming to realize is you need to be actively probing your model to see if it is, biased along particular groups, right? And so there are particular characteristics, which are sometimes called sensitive attributes or protected attributes, that was actually originally outlined, I think, in the Civil Rights Act in the 1960s, that still hold true today. And so what you really need to be doing is assessing how your model might be treating these different groups differently, right? And so sometimes that is called disparate impact, right? You want to know if your model has a disparate impact on these different, these groups represented by these sensitive attributes, even if your model is not trained with information about an individual's race or sex or education level. You still need to be able to check to see if your model is treating, say, men different than women, or people with a university degree differently than people with a high school diploma. Okay. Now, there are a number of different ways of looking at fairness. I'm just going to touch upon two that we see most commonly in practice. And the first one here is something called demographic parity. Now, demographic parity is essentially stating that the acceptance rate, or the positive outcome. So let's take, for example, approval for a loan, right? The positive outcome here would be getting approved for that loan. So if you take that example of loan applications, and you are trying to attain demographic parity along the lines of, say, the sex of an individual, that means that if you have 100 men and 100 women applying for this loan, then regardless of all their other, I would say that for their financials or any other characteristics, the same exact number of men and women should be accepted for those loans, right? And that is something called demographic parity. Now, one of the things that makes this, more widely used in practice is the fact that you don't need to know the ground truth. So oftentimes when you're, assessing a model for performance or fairness or something like that, you need to know what the ground truth was. Did this person actually, pay back their loan, or was this person actually kind of qualified? And I'm using quotations here, but essentially you need to know what the ground truth was for a lot of other fairness metrics that might come up. But for demographic parity, you're just looking at the acceptances that you're handing out, or the positive outcome that you're handing out to individuals. So this is a common metric for fairness. Another one that we see quite often is called equality of opportunity. And really the core idea here is that people shouldn't be denied based on their group identity, right? And so let's say, going back to that loan approval example, let's say all of the financial statements like payment history or whatever else you're considering in this model, let's say all things being equal, if just the sex of the individual is different, right? They should not be denied just based on that group identity, right? So if you're ensuring equality of opportunity, what you're actually doing is making sure that the false negative rates, which essentially equates to like an incorrect or rejection, you're making sure that the false negative rates are the same across all of your groups, so that people are not, unfairly denied access to credit based on their protected or sensitive attributes. Okay, and there are really a number of other definitions of fairness based on particular use cases, based on the constraints of the problem that you're facing. So it could be things like making sure that the true positive rates are the same, or even the false positive rates are the same. Depending on your use case, you might want to consider different metrics for measuring fairness, and these often don't equate with each other. So I think it requires a nuanced understanding of your use case to think about what fairness metric makes sense to try and kind of create some equivalency between your groups, and then be able to advocate for that if you are kind of undergoing a bias audit of some kind, right? And this really is kind of an emerging area of regulation. I mean, I think when I'm talking about loans, like fair lending comes to mind. I don't know if any of you are kind of in the fair lending space. That actually seems like one of the more robust areas in terms of like regulation around bias and fairness, but it's coming to other areas as well. And so I think that having a justified reason for selecting a particular metric, I think is going to be important here. And hopefully you all kind of understand your use cases well enough to think about what metric makes sense. And so let's say we have identified that our model is biased around a particular sensitive attribute. Like, what are the next steps? Like, we've identified possible sources of that bias. We've identified possible metrics to use. And I'm going to touch upon, kind of three maybe different ways to approach this idea of bias mitigation, and kind of broken down by like when in the pipeline that intervention is actually occurring, right? And so on the early end of the machine learning pipeline, we can talk about pre-processing bias mitigation, right? And so that oftentimes addresses issues where, for example, your training data set didn't cover a lot of the groups that your model is making decisions about, right? That you have kind of an incomplete data set. And so one of the possible approaches to mitigating that type of bias is to get more representative data, right? If you've identified that your model doesn't have much data that represents women applying to your loan, then maybe you need to supplement your data with more data from women. And I've seen people effectively use synthetic data generation for supplementing their training data sets, right? Because oftentimes training data is hard to come by. So I think that there is actually a case to be made for synthetic data generation to supplement your training data set to address bias. So that is, kind of early on in the machine learning pipeline here. You could do this kind of pre-processing bias mitigation. And then there's the in-processing. And so this is where you're actually changing the model itself, the model's internals, like whether it's the architecture you use or what your model is taking into account when it's optimizing its predictions, right? Like there have been cases where, you can actually, in addition to having some kind of validation involving, accuracy or the, traditional performance metrics, you could also kind of optimize your model for things like fairness, right? You want to minimize the discrepancy between different groups while your model is model is being trained, right? And so that is kind of what's considered an in-processing strategy to bias mitigation. And then on the tail end of the pipeline, there is something we call post-processing mitigation, right? So in this case, you're not actually changing the training data. You're not actually changing how your model was trained or the model architecture itself. Instead, you're adjusting the model outputs, right? And at Arthur, we tend to prefer this post-processing approach for a number of reasons. One is that it's less kind of invasive, right? You don't have to mess with your training data. You don't have to kind of tinker with the internals of your model, whether it's the training process or the architecture. You can adjust your model's outputs to attain these different fairness, metrics, so that you don't have to make significant changes earlier in the pipeline, which oftentimes involve a lot more work and disruption. Rather, you can change the outputs of your model, or adjust the outputs of your model to reflect the fairness you would like to see in your model's outputs. And I will actually put in a plug for a Python package that was recently released by one of our researchers called Downstream Fairness. It's an open source Python package. It's totally free to use. It's as simple as pip install downstream-fairness. And it has a really kind of a beautiful, elegant walkthrough of how to adjust your model's predictions to ensure fairness while maximizing performance. So I know that that is obviously a concern for people. You want your models to be performing well, but this isn't the case where you have to. It's not always the case where you have to sacrifice performance to attain fairness, right? These two can go hand in hand. So really quickly, I think I'd like to show you all what monitoring for fairness looks like in the Arthur platform, and we can then maybe transition into questions after that. But essentially, this is our monitoring tool. You're just kind of seeing the landing page, which has information about your models and alerts and things like that. But I'm just going to jump to a conversation about fairness. If you have any questions about performance or explainability or anything else like that, I'm happy to kind of follow up with you all. But on this page, you see this top chart here is performance. Down here, further down the page, you see a section devoted to fairness. Now, this is a model that is essentially just trying to predict whether or not an individual is a credit risk, right? And so, we have provided the platform with a series of sensitive attributes. So in this case, sex, education, and age. And we want to see how our model might be treating these different groups differently. So first off, you would select your metric of interest. So for example, we talked about false negative rates, right? And that is, oftentimes called equality of opportunity, right? We don't want people to be rejected just based on the fact that they are, male or female or of a particular race or age. And then, further down this section here, you see this fairness threshold toggle. So this essentially refers to, the amount of discrepancy that you're willing to tolerate in your model's outputs before you deem something is unfair, right? And so you can imagine that there are cases where a certain degree of discrepancy is tolerable. Like I'm thinking of, for example, like in the pharmaceutical industry, right? Certain medications might be more targeted towards people of a particular, race or sex, right? And so in that case, a certain degree of discrepancy might be okay, right? You're actually, tolerating something like that. So this is a variable threshold. Oftentimes what we see in use cases, and I don't think there is at least to my knowledge, there is not a hard line about what discrepancy is tolerated and which is not based on industries. We often see things like 15 or 20% discrepancy between groups. And so what we're doing here is that now we can actually probe our model to see in this case, how is our model treating individuals of a different sex differently, right? And so what we're doing is we're comparing it to a baseline. So in this case, males are our baseline. And you can see that there is this, variable disparity between males and females in this case, right? Even peaking at, something like a 30% disparity between these groups. Now, we had set our fairness threshold here at 15%. So this is an indication that, our model is actually unfair, like by our own standards, right? And by this metric that we had discussed, equality of opportunity. And so, being able to identify this and frankly, to present those findings to whether it's like model governance or auditors or regulators, I think is going to be very critical for pretty much every industry, if it's not already critical for your industry. So having a way to visualize and identify this quickly before kind of things kind of leave the stable, so to say, I think is pretty critical. I'm happy to take any questions or anything. That's most of the prepared content, but I'm interested to hear what types of things you all are experiencing, what questions you have, or any comments for anything we've discussed so far. Let's see, pull up the chat. Oop. Actually, I'm kind of wondering, so for the people that are on the call, this wouldn't be, widely available or public knowledge, but if you could actually put in the chat, like what industry you're from, because I don't actually know off the top of my head. And so I'm curious to see like what types of industries are actually, kind of, seriously considering this. And actually, in the meantime, we have a question. Okay, how does fairness apply to large language models? That's a good question. I think, pretty much everybody right now is thinking about large language models. And certainly you should be thinking about fairness as well. But this is a slightly different, I think, approach to fairness, because right now, most people that are using large language models are relying on these, foundation models or pre-trained models that are provided by companies like OpenAI. And, what OpenAI has done is they've taken their language models and kind of adapted them for chat purposes, right? Or for question and answer purposes, for example. And so when you are interacting with one of these models, OpenAI has set, kind of an API to monitor their outputs for, language, which is kind of like unfair or toxic. And so I don't think that negates the company that might be like using a service like this from thinking about fairness. Most of the approaches right now to assessing these large language models for fairness involve having some kind of like an auditing prompt system, right? Where they will kind of feed the large language model like an open-ended sentence like, the CEO's name was blank or is blank, right? And, essentially what they're looking for is, bias or stereotypes in the outputs of these models, right? And so you could imagine that, a model with no interventions or anything, if you said the CEO's name is blank, it would likely be a man's name, right? Just kind of, anecdotally, that's what I suspect, right? But, if you would want your system to be, somewhat more fair or in this case, like neutral to stereotypes, you could assess it for things like, stereotypes by prompting or auditing these models. That's most of what I'm seeing at the moment. Yeah, I'm happy to answer any follow-up questions if you have any interest in that as well. Okay, another question. So there are a lot. So the question is, how do you rank fairness concerns compared to privacy or performance? And I touched upon this a little bit. And I think there's this misconception that any attempt to make your models more fair or adjusting outputs or your model internals or training data set in any way just naturally comes with a degradation in performance. That turns out not to be true. And I think that there are actually even cases where encouraging fairness in your models actually improves your model's performance. And there's also an element of thinking about kind of the downstream impacts of your model, right? And so you could imagine that like maybe your model performance in terms of your accuracy metric of choice maybe suffers a little bit from say including more women in your training data set, right? But if you think about the actual business impact of a model, you can imagine that like, making your models more fair towards women that are applying for loans means that you're actually generating more revenue, right? So, certainly there are cases where adjusting model outputs might change your like, F1 score, for example. But when you're thinking about this holistically, it's oftentimes not the case that making your models more fair just comes with this degradation in performance, right? And so certainly, I think that that is kind of not really certainly something to be concerned about, but not a deal breaker, right? Don't let thinking about degradations in performance stop you from thinking about fairness. Yeah. Another question. Can you suggest techniques to compare fairness metrics between different models? Yeah, that's a good question. I'm not sure I totally understand the context, but okay, so let's say you have models that are, this is kind of going back to this conversation about what fairness metric is appropriate for your model, right? So if you think about, for example, medical diagnostics, right, where you really need to be thinking about the cost of, say false negatives versus false positives, right? And so oftentimes what you've seen, there are prominent examples of this where for certain races, they might be getting a higher number of false negatives than other races, right? And so this is something where the cost of false negatives is very, very high, right? If your doctor is telling you that something is not cancerous when in fact it is, the cost of that is very high. So this just kind of goes back to keeping in mind the context when you're thinking about different fairness metrics for different models, right? And that really kind of comes down to the actual use case and what the cost of metrics are. Hopefully that addresses your question. Another question that came in. So how do you suggest that we use sensitive attributes for assessing fairness when we're not allowed to include them? Okay, so this question is related to, I guess, certain industries where you are not allowed to have information about an individual's race. Like they kind of, segregate roles, like where data scientists are oftentimes not even privy to information about an individual's race or sex or other sensitive attributes. And they're certainly not allowed to kind of include them as input features into the model. And so I think really the approach here, and this is kind of what Arthur has implemented, is to allow the inclusion of non-input attributes to track against, right? So even if certain features were not included in your model in the training process, you should still be able to track your model against these particular attributes, right? So having a different workflow and different visibility on these sensitive attributes, I think is critical to actually putting something like this in practice, right? Because there are regulations around who has visibility into certain attributes. So having this different work stream where you can incorporate some of these elements and still track your model against them, I think is critical, and for really any approach to measuring fairness, and that's something that Arthur has actually implemented. Okay, I think we're at 2:30. So that's time from what I gathered. But once again, if you want to continue this conversation or if you have any thoughts or concerns, you can reach out to us at Arthur. You can reach out to me in particular. It's just akash@arthur.ai. I really am enthusiastic about this and, happy to carry on the conversation. Oh, I'm seeing In the example on the screen, less that high school was labeled as biased. From a financial perspective, they could be higher risk loans than, yeah, postgraduate, for example. How do you explain if it is bias or attributed to level education? This is a great question. Okay, so, once again, I think it depends on legally what you're required or what you're allowed to include in your model, right? Because there are going to be times where, in this case, for example, education level, it's clearly correlated to, the likelihood that someone would be able to repay a loan, right? And that's just a fact of the matter. But I think that, when you are legally kind of obligated to not include that information, I think you need to follow the law. That's my example, right? So that's my perspective. So, because sometimes a certain degree of bias, right, it actually, it is reflective of a real world pattern, right? It's not always an unfounded stereotype. It sometimes is a real world pattern. But I think it has more to do with like, looking forward into the future, what types of things are we okay with propagating, and what types of things do we want to kind of mitigate, right? And so certainly the law has kind of stepped in and I think we'll continue to step in and kind of indicate what types of things we are allowed to train our models on. But I think that there are going to be some real world patterns that we want to maybe not propagate, maybe disrupt those patterns, right? Where we don't want there to be such a high correlation between whether or not somebody graduated from a postgraduate education and whether or not they're able to repay a loan, right? Certainly it'll affect like your loan amounts and things like that. So this is a difficult question. That's just my perspective on it. But I think that in the case of loan approvals, my suggestion would be to follow the law. Yeah, this is a really good question though. All right, I think that's all the questions that have been submitted. Yeah, well, thank you for taking the time to be here and to really think about these issues. I really do think that it affects everyone, and as AI and ML is just going to infiltrate more and more of our lives, I'm glad to see that there are so many people that are actively thinking about this. So yeah, thank you all for joining us.